Okay, so tomorrow, this is what I'm planning for tomorrow. Tomorrow we're having another quiz, but it's going to be a bonus quiz. You guys understand? Going to have 7 problems from last night's homework. Exactly. I'm not going to even change the number. You know what I mean? No, I'm not going to change the number. Otherwise, you just go memorize the answers. That's sad. So, bonus quiz tomorrow. What is tomorrow? Friday. We'll give you 7 problems, 1 point each. So that if you get 7 out of 7, that will raise your grade 1%. Because it's going to have less than 700 points in this quarter, so 7 points will raise your grade 1%. Plus, I'm going to give you 1%. So this could raise your grade 2% at the end.
Are we gonna play tennis?
No, we're not playing tennis. You guys not going to get anything anyway. So no, we're not playing tennis. Okay, so you guys understand what's happening tomorrow? 7 problems. So basically, you have to do things, right, to get to the stage where you can do what you did on today's quiz. Okay, so questions on last night's homework. Go. You guys better ask.
Wait, are you gonna
Wait, how many problems were there on last night's homework? Wait, what is today's date? I'm be looking at the right one. 5 to 23 odd, 29 to 39 odd. So it's all gonna come from there. I know what I do. I'll just change the sine to a cosine or something like that. But it's the same problem. Yeah, go. 23. 9. 35. 19. 29. What? 17. Again, thank you for giving it to me in order. 31. 37. Why not just write all already?
Yeah.
Just write all, 911, all. You guys gotta do something. Man, this is disastrous. Okay, 21. Look, I can do problems all day long, but until you guys sit down and grind out the problems, it ain't gonna help you one bit. Sine theta is equal to cosecant theta. First step, change everything to sines and cosines, just like proofs, right? So did you change the cosecant to 1 over sine? Did you guys do that? Okay, and then when you have a fraction in an equation, what do? You multiply both sides by the LCD, which is sine theta. So you get sine squared theta is equal to 1. Square root both sides, so you get sine theta equal plus or minus 1. See how these numbers have to be something that you know. If it comes out to something that you don't know, then we can't do it. Okay, so now, this is like today's quiz. Sine of what angle is plus or minus 1?
90 degrees.
Okay, what are they asking for? Radians? Okay, they're asking for radians, so tomorrow I'm going to ask for radians. Yeah, so it'll be, what's the one up here? Pi over 2, and sine is negative 1 down here, 3 pi over 2. Boom. Yeah, let's see that 21, that was an easy one. 23. Where's 23? 23. So, tomorrow, what if I change that to cosine and secant? It would be the same problem, except it'll come out to cosine theta is plus or minus 1, right? Okay, you guys can do that, right? 20, where's 23? Cosine 2 theta. This looks like the one I did on the board last time. No, it's a little different because the one I did on the board was sine. Did you guys even learn from those examples? Okay, cosine 2 theta has 3 identities. Which one am I going to use since that side is cosine? Since you want to make everything all the same variable. Yeah, you want to use the one with cosine, which is 2 cosine squared theta minus 1. And look, if you don't know your identities, again, how can you even pass the test? You got to know your identities and values. That's the minimum. And then you gotta be able to put everything together by doing algebra. So when you have a quadratic equation, you make one side 0, right? And then it should factor. So 2 cosine, cosine, 1 and 1, minus plus. Okay? And then if something times something equals 0, either this is 0 or this is 0. So what would make this one 0? Cosine theta would have to be, negative half. And cosine, for this factor, cosine theta would have to be 1. And look, these are both numbers we're supposed to know, right? Cosine of what angle is negative half? How many times I did this already? Oh. 2 pi over 3. This is, see, that's why we have the speed quiz, because so when you get to this step, you can just write down the answers already, right? 4 pi over 3. And cosine of what angle is 1?
0. Oh, it's not 0.
Yeah, 0. And 2 pi.
Oh, yeah.
Now, the book's direction, this is the book's directions. They go greater than or equal to 0, but less than 2 pi. That's because 0 and 2 pi are the same place, that's why. That's why they don't include 2 pi. But my directions, it includes 2 pi. That's because in calculus, we include 2 pi, that's why.
So we take off. We'll take off.
Yes, so tomorrow's directions are going to be like this. So you need to write 0 and 2 pi. Yeah? Just like on today's quiz, right? Didn't I put that on today's quiz?
0 and 360.
Yeah, so if you put down 0, you got to put down 360. Okay. You know what? This is so confusing. Let's just cross them off as we go. Look, what is the number 9?
Or 17 or 19.
Okay, let's do number 9. We're going backwards now. Are you? Ah! Number 9? You wish you get one this easy tomorrow. Look, it's also not set up for you. If something times something equals 0, that means either this one is 0 or that one is 0. What makes this one 0? Tangent theta would have to be 1. And this one, secant theta, would have to be 1. Okay? And again, if you don't like secant, take the reciprocal of both sides. What's the reciprocal of 1? 1, right? You have 1 over 1, you flip it over, you still get 1 over 1. And these are numbers you're supposed to know. Tangent of what angle is 1? Pi over 4, 5 pi over 4. Cosine of what angle is 1? 0 and 2 pi. Okay, so cross out 9. Okay, I'm pretty sure I'm not going to give the problem tomorrow because it's all factored for you. I want you to factor it on your own. That's the purpose of this whole thing. Okay, number 17 is next. 17. Cosine theta equals sine theta. And you know what another thing is? Hardly anybody even coming in for help. A lot of us need help. Just come in. What are we waiting for? It's the end of the quarter now. Now it's like the act of desperation is going to save you. Okay, now there's lots of ways to do this problem. The easiest way, I think, is just to think about it. Where on the unit circle is cosine equal to sine? Where do cosine and sine have the same value? Pi over 4, because they're both root 2 over 2, right?
Yeah.
And 5 pi over 4, because they're both negative root 2 over 2, right? So that, to me, that's the easiest way to do it. So you just think about it. Pi over 4, 5 pi over 4. Okay, but if you don't like that explanation, how about divide both sides by cosine? If you divide both sides by cosine, you get tangent theta equals 1. Where is tangent theta equal to 1? In fact, we just did it right here, right? So you get that. And if you don't like that explanation, how about divide both sides by sine? And then you get cotangent theta equals 1. You get the same answer. Either way, whatever, just do it. That one might be on tomorrow's quiz. Except, I'm going to change the cosine to sine and the sine to cosine. Let's see if you guys catch it. Only one person caught that joke.
Yeah.
Are you guys serious? Is this for real? Or am I dreaming? Is this a bad dream? You guys don't get it?
Can you repeat the joke?
What a joke.
The joke. Yeah, what exactly? What a joke. Tomorrow, I'm going to change the cosine to sine and the sine to cosine.
Same equation.
It's the same problem!
Right.
If I have to explain the joke, that's so sad. That's just, oh gosh. That's not even a joke for someone. We're just befuddled already, yeah? Tangent theta equal to sine theta. Okay, change everything to sine and cosines, just like proofs, right? Because I don't see any identity I can use right away. So change the tangent to sine over cosine. I'll tell you what, as we do these problems, I'll tell you which ones I like for the quiz. Like, I like that one. And the first two were pretty good. Okay, when you have a fraction, multiply both sides of the equation by the least common denominator. So you're going to have sine theta is equal to 2 sine theta cosine theta. Hey, this looks like a problem I showed you last time. Cancel sine theta from both sides. Were you guys here last time? Cancel sine theta from both sides. No, because you just lost two solutions and then you lost your 1 point for bonus right there. No, you never cancel a variable from both sides of the equation because you're going to lose a solution. Now, some of you are probably thinking, Mr. Park, but over here, you divided both sides by cosine theta. Yeah, but I didn't cancel it from both sides of the equation. From the left side, I canceled it out, but not from both sides. If you cancel a variable from both sides of the equation, you lose solution. So what did I tell you to do last time? And I'm sure your Algebra 1 teacher taught you this. Or do I have to show you what I showed you last time?
Yes.
Okay, if you have x squared equal x, can I divide both sides by x and get x equal 1?
No.
No, because you lost the solution, right? What you're supposed to do, I don't know why I show you things. You make one side 0, you factor it, and so you have two answers, 0 and 1. See, you only get 1 here. So what you need to do is make one side 0. In fact, anytime you're solving equations, if you make one side 0, you're going to be going on the right track. And then you factor, what can be factored out from both terms here? Sine theta, and you get 2 cosine theta minus 1. And again, if something times something equals 0, either this one is 0, which means sine theta is 0, or this one is 0, which means cosine theta equals 1/2. And again, these are all numbers you're supposed to know. So sine theta is equal to 0. Where is sine 0? See, I can do this. You know what? I'm calling you. I want to see the arms.
Pi, 2 pi, times.
Pi to 0, pi, 2 pi. Cosine theta equal 1/2. Yamashita. Okay, that's fine. Pi over 3, 5 pi over 3. See, you guys watch me going, what is Mr. Park doing? That's to help you get the answers. Now, the meat of this next test is going to be this right here. This is the meat of the next test. Solving equations. Okay, next one we got is 29. Flip the page. Okay, this looks like this is something that'll be there. Why? This is so sad. I have to give you bonus points for homework. Okay, change everything to just one variable if you can. So, what should I do? Well, there's only one thing you can do. What am I going to change cosine squared theta to? 1 minus sine squared theta. In fact, this is an example I did last time. Okay? Right? The Pythagorean identity. Now multiply out everything. 1 plus sine theta equals. Got this 2 got to be distributed now. In fact, this looks almost hauntingly the same as the other one. And it's a quadratic, so you make one side 0. So you get 2 sine squared theta plus sine theta minus 1, like that. Put it in order, and it should factor. So 2 sine theta, 1 plus minus. I'm just gonna do this quickly. I'm assuming we can factor. Something times something equals 0. That means this one is 0 or that one is 0. So this one means sine theta has to be 1/2, and that one is saying sine theta has to be -1, and then these are all numbers we're supposed to know, right? Okay, sine theta is 1/2. Ignacio.
Boom.
Okay,
But
close enough. Pi over 6, 5 pi over 6. Sine theta is -1. Izuo. No, that's cosine. No. Okay, yeah. 3 pi over 2. See, we're not playing this game enough. No, for real.
We can just play the game.
What?
Play the game.
What game? No, I'm talking about this game.
No, yeah, play that game for bonus points.
No, no. I'm not gonna give you. I don't want to give you bonus points for things you're supposed to do. Like, hey, you're breathing today. Plus 1. Hey, you're walking. +2. What?
Okay, that's
What the park is going on? 2 sine squared theta minus 5. Look, the thing is just set up.
you need to use that one.
Okay, but maybe I'll give this one, but this one's kind of easy because look, it's all set up already. Look, one side is 0. All you gotta do is factor it. So 2 sine theta, like at least move this on that side, make you do something, right? 3 and 1, so 3 and 1 minus minus. So sine theta is either equal to 3 over 2 or 1. Okay, now what? Are these numbers we're supposed to know? Mr. Park, I don't know this one. That's because we crossed it out. How come sine theta can't be 3 over 2? Because the biggest sine and cosine ever gets is 1. Right? Because look at the unit circle. Think about it. Here's the unit circle. What's the biggest the y coordinate ever gets? 1. What about the x coordinate? What about the smallest it ever gets? -1. So if it's not between -1 and 1, it's impossible. So that's why you cross it out. You guys get it? So basically you only have this to worry about. Sine of what angle is 1? Develop.
I.
Sine, no, sine is the y value. Where is the y coordinate?
Pi over 2.
Okay, there you go, pi over 2. Okay, 35. See, but you guys copy it down. You gotta do it again. Otherwise, you didn't really learn it. 35. Tangent squared theta is equal to 3 over 2 secant theta. Okay, now, do we see an identity we can use right away? Hey, you somebody. Tangent squared theta is yung?
1 minus, wait, secant squared minus 1.
Yes, secant squared minus 1. How many of you know that? Because what's the identity? 1 plus tangent squared is equal to secant squared, right? Yeah, so therefore what is tangent squared? Secant squared minus 1. Now, how many of you, like, Mr. Parker, no can? Okay, so let's pretend you know can. Let's just pretend you know can. So, Mr. Park, I just don't like this one. Okay, then what do you do then if you don't like that one? Skip to the next problem? No, I told you. Change everything to? Okay, so if you don't like to use that identity, then don't. Just change everything to sine and cosine. Because that's going to work. And that's, well, 1 over cosine, right? So multiply both sides by the LCD, which is 2 cosine squared, correct? Okay, so if I do that, this cancels out, so you get 2 sine squared equals this times that, the 2's cancel out, and one of the cosines cancel out, and what do you get then? One of the cosines cancel out, so you get cosine theta 3 times. Oh my gosh, this is algebra. That's why we have problems. And then, if I want to make everything just 1, I'm gonna change the sine squared to, since that, we did this in a previous problem. What is sine squared? 1 minus cosine squared. See, it's a little bit longer, but at least it's doable, right? Distribute the 2. 2 minus 2 cosine squared theta. It's a quadratic. I just gotta make one side 0. 2 cosine squared plus 3 cosine minus 2, and it should be factorable. Otherwise, I'm not gonna give that problem to you. Unless I do. So, 2 and 1 plus and minus. Did I do that correctly? Okay, so if something times something equals 0, how many times has that happened? Either this one is 0 or that one is 0. What will make this thing 0? Cosine theta would have to be 1/2. And for this one, cosine theta would have to be -2. But we cross that out because again, the smallest cosine can ever be is -1. You can't go smaller than -1, so you just cross it out. So cosine theta is 1/2, Arita. Mm-hmm.
And 500.
There you go. See? After a while, you don't even have to use the arms already. No, for real, if you cannot do this, you fail the test. It's that simple. You cannot do the test. Okay, 37, last one, finally. What time is it? We think today's lecture is very short. 37. 3 minus sine theta is equal to cosine 2 theta. Okay, now, cosine 2 theta has 3 identities. Which one am I going to use in this case? Noah.
I'm sorry.
So now just start zoning out.
No, I was ready, sorry.
What if I started zoning out?
2 cosine.
Wait.
2 cosine, 2 cosine sine. No, 2 cosine squared theta. I'm sorry, I'm out of it.
Yeah. Look, this side is sine, right? You want to make everything the same, so you want to use the one with sine in it.
1 minus.
Chi.
1 minus 2 sine squared.
There you go. And then look, it's quadratic again, so make one side 0. I would say tomorrow, out of the 7 problems, probably 5 of them will be quadratic, because that's what this whole chapter is about. Right? And then you add, subtract 1, so that's, it's unfactorable. How many people got this far? It's unfactorable, yeah? So what do? You gotta use quadratic formula. So, sine theta is equal to negative b plus or minus the square root of b squared minus 4ac, which is 16, all over 2a. But then, what happens when you have a square root of a negative? It will be imaginary then, right? So then, how can sine be imaginary? So no solution. Now tomorrow, I'm not going to make something come out to no solution, so this problem is not going to be there. I want you to actually write down solutions. So do you guys understand what's happening tomorrow then?
Is it a speed quiz?
No, just a regular quiz. 10, 15 minutes.
Okay.
7 problems, 1 point each. This is going to raise you, look, I'm trying to help you guys. This is going to raise 1%, which in turn is 2%. So then, if you get 77.5, oh yeah. Or 67.5, oh yeah. Yes.
So this homework or today's homework? What is this on?
Last night's.
This homework right here. Well, how come everybody's out of it today?
Thursday.
It's not even Friday. Oh my goodness.
Somewhere.
Garcia, you gotta go? Okay, you gotta watch the video for the lecture then. And Chun, you know I'm making videos every day?
No,
Are you watching?
I don't watch that video.
Wise.
I have.
All right, today's lecture again. Okay, in order to do tonight's homework, you have to know your values again. It all comes back to that. If you don't know your trig values, It's all over but the triangle right here.
Yeah.
So, okay, today we're going now, if you look at the thing, we're going back to 8.1. So tonight's homework is 8.1 and 8.2, but look, it's a little bit problems. You just have to understand this concept. Okay, what do you do when you see something like this? Cosine inverse 1/2. Now we already kind of talked about this, right? Because remember when it comes up to, remember that thing we did on our calculator? So when you see something like this, okay, this is what you gotta be thinking. Cosine inverse 1/2 means the cosine of what angle is equal to 1/2. We're looking for an angle that corresponds to this value. So when you see an inverse trig function like cosine inverse, sine inverse, tan inverse, and by the way, that does not mean 1 over now. See, in mathematics, see, it is confusing sometimes, like x to the negative 1 you were taught is 1 over x. But when you use it with functions, you know, like this, that does not mean 1 over f now. That means the inverse of f. And you guys remember what an inverse is? If you know any graph, how do you graph its inverse? We did this in algebra 2a and 2b. You switch to x's and y's. Does that sound familiar? Like for example, here, let me just give you an example. Here is the graph of e to the x. Does that look familiar? What if I ask you to graph the inverse of that? Well, if you switch all the x and y coordinates, you get a graph that looks like that. And notice that they're symmetric about the line y equal x. That's what an inverse is. And by the way, just for reference, what is the inverse of e to the x? Natural log x. Is that ringing any bells? No bells. Okay, I just want to make that clear before we start. Okay, so when you see this, this is what you think in your head. Okay, here, so here's you. Here's you. This is what you're thinking in your head right there, okay? Cosine of what angle is 1/2, but the answer has to be within a certain range. It has to be between 0 and pi over.
Only,
Yeah, because that's the range. Okay? So let's see if we can do it. Cosine of what angle is 1/2? Okay, where is cosine of 1/2? It's either there or there, right? Okay, but there's only one answer that's going to be between 0 and pi.
I agree.
It's pi over 3. Now, there's another one over here, 5 pi over 3, but is 5 pi over 3 between here and here?
No.
Or if you think about degrees, is 300 degrees between 0 and 180? No, so you have to pick the one that's in the range. Okay, let's do another one. Sine inverse root 2 over 2. Okay, so here's you. This is what you're thinking. When you see this, you're thinking sine of what angle is root 2 over 2, but the answer has to be in a certain range, and that range is negative pi over 2 to pi over 2. Where are you coming up with these? These are standard mathematical ranges. You have to know that. Okay, so this is how you think. Sine of what angle is radical 2 over 2? It's either there or there. Okay, that's pi over 4 and that's 3 pi over 4, right? Which one of those falls between negative pi over 2 and pi over 2? Pi over 4. That's right, so that's the answer. Or if you want to give me degrees, 45 degrees, I'll accept that. So now you can either give radians or degrees, unless it specifies in the problem. Yeah. Okay, so the key to doing these problems is you have to know the ranges. So Mr. Park, each one of the inverse trig functions has a range? Yeah, there's 6 inverse trig functions and they all have individual ranges. However, I boil it down for you to make it simpler. Because if you read the book, it sounds like you gotta memorize like 6 different ones, but you really don't. So, there are only 2 ranges you gotta worry about. This one and this one.
What is on the green?
What?
What is that second one?
What do you mean the second one? That's the range. That means the answer that you give has to be in that range. So if your answer is not in that range, it's wrong. It has to be in the range. So which ones fall between 0 and pi? Well, obviously cosine inverse, secant inverse, and cotan inverse.
So sine, cosine, and tangent is on the other one?
Yeah, so this one will be the other three, which of course is sine inverse. Hey, you dummy. Sine inverse, cosecant inverse, and tan inverse. Now, I've been teaching pre-calculus for years, so every year the students go, Mr. Park, is there a way to memorize this? Yeah, how about just memorize it? Or, I just made up something one time. So, hey, look, just look at the number of C's. See, look, there's only one C, one C, one C. So if there's an odd number of C's, then it's between 0 and pi. Because then look, odd. I just made it up, and it works. Okay, what about this one? There's 0 C's, there's 2 C's, there's 0 C's. Those are even numbers, right? 0 and 2 are even numbers. So if you have an even number of C's, then it's the other one.
Where'd you put the even?
Okay, here, you want me to make up something then? Oh, because 2 are even numbers.
I like that.
Or how about this? You take this, put it like that, take this thing, put it like that, and that stands for even. I'm just making up something. Whatever it takes. Like, how did you guys memorize the capital of the United States?
Never did.
Okay, so these are the, okay, I'm going to tell you right now, the key to doing the inverse trig functions is you got to know these ranges. Now, it's printed in the book. I don't know if they print it all together or what, but that's what you got to know. Okay, let's just do some more so we get used to it. Tan inverse radical 3. So, after a while, hopefully you don't have to draw this picture of you like that, okay? So, this is what you think in your head. Tangent theta, tangent of one angle is radical 3, but the answer has to be in the range. What's the range for tan inverse? It's cool. Look,
Negative pi.
it has an even number of C's, so it's the other one. It's this one, the one with the 2's. I don't know how you want to remember it. Okay, so here, let's do it. Tangent of what angle is radical 3? Where is that? Wouldn't that be here and here? But which one of these falls between here and here? So pi over 3. Is pi over 3 in between here and here? Or if you want to think about degrees, is 60 degrees between negative 90 and positive 90? Yeah, that's the answer. Oh, I get it, Mr. Park. So if this number is positive, the answer will be a first quadrant angle. Yeah, it will be. So anytime that's positive, the answer is going to be a first quadrant angle. And everybody knows the first quadrant ones, right? At home. Okay, but you know what the problem is? This is where students have problems. What happens when it's negative? That's when the problem occurs. Okay, let's do this. Sine inverse negative root 3 over 2. So this is what you're thinking in your head. Sine of what angle is negative root 3 over 2, but your answer has to be in this range here. See, they've got to be between negative. I'm not going to write it down. I'm trying to wean you off this. Okay, where is sine negative root 3 over 2? Here and there, right? So what is that? Which one is that? 4 pi over 3. Down is 5 pi over 3. Which one of those two falls in this range here? None of them. Neither of them. How can 4 pi over 3 or 5 pi over 3 be between negative pi over 2 and... See, this is, or converted to degrees, negative 90, positive 90. This is 240 degrees and that's 300 degrees. Is 240 or 300 degrees between negative 90 and 90? No, so what do? Ignacio.
Where the heck is
We learned it on the first day of school. I forgot. It's serenity now when you calm down. A negative angle measurement means you go clockwise. So negative 90 degrees means you go clockwise 90 degrees, so that would be down here. So between negative 90 and positive 90, that's where your answer has to be. Negative 90 and positive. Oh, it's this one, Mr. Park.
No.
But then you already told me 300 degrees can be the answer, or 5 pi over 3, because it's not in there. Yeah, that's right, it's not. So 5 pi over 3 is not the answer. So what do I do then? How do I get this angle? Because this is the answer, but it's just not 5 pi over 3. How do I get that number to be between negative pi over 2 and pi over 2? You subtract 2 pi. Remember, if you have an angle on the unit circle, you can add or subtract 360 degrees, right? Or any multiple of that, and you end up at the same place. So what would happen if I subtract 2 pi from that? Which is 6 pi over 3. What do you get? Negative pi over 3 is your answer. Just remember, the answer has to be in this range. If it's not in the range, that's not the answer. That's why I boxed this. That's why it's so important. Okay, let's just keep on going. Cosine inverse negative root 2 over 2. Okay, now let's try to do this without writing anything down. Cosine of what angle is negative root 2 over 2? What are you thinking? I guess we gotta write something down. Where would cosine be negative root 2 over 2? Either there or there, right? So this one is 3 pi over 4, and that one is 5 pi over 4. But the answer has to be in this range right here. So which one is the answer? No, one of them is in the range. 3/4. 3 pi over 4 is the answer. Look, 135 degrees is between a 0 and 180, right?
Right.
Think about it. Here's 0, here's 180. Why do I put it on opposite side? Is 135 in between there? Yes, that's the answer. Okay, let's do another one. Tan inverse, I don't want to do the same thing, negative 1 then.
It's negative in the second and third quadrant.
No. Tangent is negative in the second
Or fourth
and the
quadrant.
fourth quadrant.
That's the second and third.
Okay, so tangent of what angle is negative 1? Either 3 pi over 4 or 7 pi over 4. But which one of these falls within this range here?
3 pi over 4.
No way. This is 315 degrees. 315 degrees
Oh,
is
so-
way bigger than 90. So you gotta subtract 2 pi from it, that's right. Negative pi over 4. Are we getting the hang of it? If your answer is not within these ranges, that's not the answer. In fact, when you do these things on your calculator, the calculator has these ranges built into them, so it automatically spits out the answer in the range already. You can try it if you want on the calculator. Okay, I gotta teach you one more thing. Okay, now, the second part of tonight's homework problem is once you can figure out what the angles are. So if you haven't figured this out not by now, an inverse trig function is an angle measurement. That's what it is. Because some students, they don't really get what it is because the teacher just tells them to do it. It's an angle measurement. What angle, the tangent of what angle is going to give you root 3? It's an angle measurement. Okay? So what if I give you something like this? Sine of tan inverse, no, let's do cosine. Cosine inverse 1/2. So the first thing you do is you figure out this angle. Okay, don't even do the sine yet, just figure out that angle. So what are you thinking in your head? Cosine of what angle is 1/2, but the answer better be in that range. Okay, very good, it's pi over 3. Everybody got that? 60 degrees, if you want to think about degrees. So now, what is the sine of pi over 3, or 60 degrees?
1.
These are trig values, people. Sine of pi over 3.
Root 3 over 2.
Root 3 over 2. Oh, Mr. Park, I like it when that's positive because it's always first quadrant. That's right. The only problem comes when it's negative and then students have problems. Okay, we got 2 minutes left. Okay, let's do a couple more. tangent of sine inverse, give me a number. Root 2 over 2. 3, who said 3? If you put 3 there, sine inverse 3 means sine of what angle is 3? Think about it. Sine of what angle is 3? No more. I like that answer, Mr. Park. No solution, right?
Pi over 4.
Let's say really too.
Pi over 4 times pi over 4.
Okay, let's compute this angle first. So what are you thinking when you see this? Sine of what angle is root 2 over 2?
Pi over 4.
Pi over 4. See, when it's positive, you just got to worry about the first quadrant. It's easy. And then now, what's tangent of pi over 4?
1.
1.
Jesus.
Oh, so Mr. Park, I've got to know my trig values. Yeah. Okay, now, what would happen, okay, this is the last example. What would happen if I give you something like this, tan inverse 3/4?
Tangent of 3/4.
Now, is that a number I'm supposed to know for tangent? Tangent of what angle is 3/4?
No, no.
That's not something we're supposed to know, Mr. Park. Can I use calculator? No, you can't. Well, you could punch this in on your calculator. Your calculator would spit out. Anybody in physics?
Shayna.
Yamashita, do you guys know this one? This one is like 36.9 degrees. Okay, never mind. So this is what we do. Mr. Park, I don't know this angle, but can you draw this angle? Yeah, you draw a picture. So when it comes out to a number that you don't know, you draw the triangle. The tangent of what angle is 3/4?
Opposite.
Where do I put 3 in the 4?
3.
What is tangent? Opposite over adjacent. And then you use the Pythagorean theorem. So that angle, Mr. Park, whatever that angle is, well, it's 36.9 degrees, but we don't need to know that. Okay? So this is, everybody understand, this is the angle, whatever it is.
Yeah.
So what is the cosine of this angle that I just drew?
Adjacent over hypotenuse.
Adjacent over hypotenuse, 4/5. So when this number is not a number you're supposed to know, you simply draw the triangle.
Okay.
Okay. Wow, I thought we were gonna finish early, but that didn't happen. Okay, so tomorrow, got the bonus. I'm trying to help you guys. This is 1% on the line right here. That's on last night's homework.